1 minute smarter, every market clearer. Welcome to my channel, I'm Claire. Hello everyone and welcome back to the channel. Today, we aren't going to talk about hollow financial statements. Instead, we are going to deconstruct a technological leap happening right before our eyes, one that is almost chilling in its progress. Many Tesla owners, after upgrading to FSD V12, have experienced a sensation bordering on science fiction. The car is no longer a robot mechanically executing commands, but a living entity that seems to have developed intuition. Let's look closely at how this change manifests. Imagine driving through an intersection where a poorly parked truck blocks your view. In FSD V11 or earlier versions, the system might have acted very stiffly. It would either stop dead and wait for the obstacle to disappear or struggle within a logical forest of code, trying to find a specific bypass command among tens of thousands of rules. But interestingly, data shows that V12 exhibits a completely different trait. It acts like an experienced human driver, slightly peeking its head out to find a gap in the line of sight before smoothly navigating around. This leap from a mechanical feel to a human feel isn't just simple parameter tuning. It is a fundamental logic revolution in how AI conquers the physical world. To understand this deeply, I've spent a lot of time recently analyzing a deep reverse engineering report by Phil Bethel, a former Apple engineer and a founding team member at Rivian. Through his perspective, I found a compelling conclusion. Tesla is undergoing a total brain transplant. To grasp Tesla's current technical height, we must look back at the limitations of the V11 era. At that stage, Tesla used a hybrid architecture that Bethel vividly described as the world's most complex rulebook. While the perception part was handled by AI, it could identify pedestrians, red lights, and road edges. The decision-making and planning parts were essentially composed of traditional code. Engineers had to write thousands of lines of logical code, such as if pedestrian encountered, then decelerate, or if red light turns on, then stop. However, Bethel points out a fatal weakness in this architecture. The real world is infinite. He calls it the world's largest decision tree. But because long-tail scenarios in reality are inexhaustible, this tree can never cover all possibilities. For example, if a traffic light is broken and a police officer is directing traffic with hand signals, what does the car do if that specific rule isn't in the codebase? Or if a pile of fallen plastic bags appears on the road, should the code treat it as a hard obstacle requiring an emergency brake, or just drive over it? These logical limitations made early FSD often behave like a book-smart nerd, hesitant in complex environments and prone to mysterious jerks or stutters. Interestingly, the data shows that the arrival of V12 has completely ended this era of hand coding. Tesla has shifted entirely to end-to-end neural networks. This means engineers no longer teach the car how to drive. They simply give the neural network millions of videos of excellent human drivers and tell it, "This is what the camera sees, and this is how the human driver handled it. Go figure it out." This shift is revolutionary. AI no longer deduces through logic. It judges through intuition. Just as we don't calculate lean angles and centrifugal force in our heads when riding a bike, but instead balance by feel, Tesla's V12 now possesses this sense of balance. The foundation of this comprehension capability lies in data. I found Phil Bethel's analysis of Tesla's data acquisition methods to be very profound. In the field of autonomous driving, there has long been a debate over which is more important: simulated data or real-world data. Many competitors relying on limited fleets, like Waymo or Cruise, depend heavily on simulated data in virtual environments. But Bethel believes Tesla possesses a real-world laboratory that competitors can never match: millions of Tesla vehicles driving globally. These cars are not just transportation, they are millions of mobile sensor arrays. The most ingenious design here is shadow mode. Even if you don't have FSD engaged, Tesla's AI is running silently in the background. It observes and learns. If a human veteran driver were at this curve, how would they turn the wheel? Then, the AI compares that to its own judgment. if the human's operation is better than the AI's, or if a human takes over the vehicle, that video clip is automatically tagged as valuable learning material and uploaded to the cloud. Bethel emphasizes that Tesla's data collection is by no means a blind, needle-in-a-haystack approach. The onboard system automatically filters for interesting, useful, and peculiar scenarios. For instance, a stop sign half covered by vines, or a pedestrian riding a bike in a torrential downpour. What I find even more fascinating is that Tesla performs augmented training on these real-world scenarios in its data centers. They take a real case from a San Francisco intersection and create 100 variations in a simulator, turning a sunny day into heavy snow, making the road slippery, randomly adding lunging virtual pedestrians in blind spots, or even having the traffic lights suddenly go out. Through this reinforcement learning of real data as the base, simulation for enhancement, Tesla's AI can experience extreme situations in a few hours that a human driver wouldn't encounter in several lifetimes, achieving exponential growth in evolution speed. Next, we must talk about the most controversial, hardcore, technical point: vision supremacy. Elon Musk insists on not using LiDAR, relying only on cameras. Many experts believe autonomous driving is unsafe without LiDAR devices that can precisely measure distance, but Bethel's reverse analysis reveals Musk's deeper logic. If you have a powerful enough brain, you don't need such expensive glasses. Humans drive using only eyes. Eyes receive light signals, but the actual processing happens in the brain's visual cortex. What Tesla is building is a digital visual cortex. I found this point highly disruptive. Tesla has now bypassed traditional image signal processing, ISP. Typically, after a camera captures photons, they are first converted into images humans can understand, denoised and color balanced. But in this process, a vast amount of raw information useful to AI is lost. Tesla's approach is to let the neural network directly read the raw photon data from the sensors. To the AI, that is no longer a photograph, but a massive, high dynamic range energy field. This explains why the neural network can construct extremely precise 3D environmental models by capturing faint photon differences in pitch-black nights or blinding glare, situations where both the human eye and standard cameras would struggle to see. So, does Tesla really not use LiDAR at all? Bethel points out that, interestingly, data shows Tesla is actually a major buyer of LiDAR, but it uses it as a coach. Tesla puts test cars equipped with LiDAR on the road while simultaneously running the vision system, using the real-time road conditions generated by LiDAR to calibrate the precision of the vision system. Once the obstacle distance measured by the vision system matches the LiDAR perfectly, the model graduates, and production cars no longer need the burden of expensive hardware. This strategy of simplifying input, strengthening the brain, not only significantly reduces costs, but more importantly, avoids the data fusion trap. When the camera says it's a road and the LiDAR says it's a wall, who should the AI listen to? Tesla chose the only truth, vision. This extension of visual capability is leading Tesla toward another shocking field: species fusion. Many people don't yet realize that Tesla's cars and its humanoid robot, Optimus, are essentially the same species. Inside Tesla, all AI projects are now unified under the leadership of Ashok Ellaswamy, which means the code for FSD and the code for robots are merging deeply. We can compare the two. The inputs for both are vision systems based on multiple cameras. The brains for both are end-to-end neural networks based on the transformer architecture. And the training methods for both are imitation learning plus reinforcement learning. The only difference lies in the output. A car is a low degree of freedom system outputting steering, acceleration, and braking, while a robot is a high degree of freedom system involving fine control of dozens of joints and hundreds of muscle paths. Bethel proposes a staggering perspective. The more complex and refined AI models developed for robots will feed back into the cars. When an AI learns how to avoid pets in a crowded home or gently pick up an egg, its depth of understanding of the physical world reaches a terrifying height. Once this capability is applied as a dimensionality reduction strike on cars, the vehicle does more than just avoid obstacles. It can even understand the intent in a pedestrian's eyes or predict that if a soccer ball rolls into the street, a child will surely come running after it. This synergistic effect is something traditional car companies simply do not have. As Bethel said, can you imagine Ford developing humanoid robots specifically to help build cars? But at Tesla, it is a logical necessity. In the future, your personal AI brain might be cross-device. The hardware is just the carrier, while the soul is universal. Of course, all software ambitions need a hardcore physical foundation. Bethel gives extremely high praise to the upcoming AI-5 chip, suggesting it shouldn't even be called AI-5, but rather AI-1. This is because it is the first chip custom-tailored entirely for the end-to-end neural network architecture. When developing AI-4, Tesla was still figuring out how neural networks operated. But now, with the success of V12, the hardware team knows exactly which neuronal calculations are most frequent and where memory bandwidth bottlenecks lie. AI-5 is no longer about benchmarks. It's about achieving the most extreme inference speed for FSD on device. Furthermore, Musk's ecosystem hides other trump cards. First is Starlink, which allows every car and robot to have seamless global connectivity, not just for updates, but for distributed inference. Second is the Dojo supercomputer, Tesla's alchemy furnace, using self-developed supercomputing designed specifically for vision training to iterate models at lower costs and higher speeds. Third is xAI, whose powerful linguistic and logical reasoning capabilities are intervening in physical AI. Future cars won't just drive steadily, they will understand your complex intentions and even converse with you. This is a complete closed loop from chips to supercomputers, software to hardware, and Earth to space. After deeply analyzing these technical details, I found they all ultimately point to a very cold ledger. Bethel analyzed the economic model of Tesla's upcoming robotaxi. Current ride-hailing giants like Uber have drivers as their main cost. Meanwhile, niche solutions like Waymo, due to extremely expensive sensors and heavy human remote supervision, have operating costs of about $5 per mile. And Tesla, the Cybercab, designed specifically for autonomous driving, is expected to push costs down to a staggering $0.30 per mile. This means that even if Tesla charges $15 when Uber charges $30, there is still a massive profit margin. This price gap is enough to destroy the traditional mobility market within just a few years. But Tesla's real, killer move isn't just technology, it's scalability. Waymo's expansion is limited by geofencing, requiring extremely precise high-definition maps for every new city. Tesla's solution is universal. If there's a road, it can drive. Once regulatory approval is granted, Tesla doesn't need to buy cars slowly. It can turn millions of Teslas already on the road into money-making tools instantly through an OTA software update. This capability for capital expansion with zero marginal cost is a chasm no competitor can cross. However, as objective observers, we must confront the challenges that remain unsolved. First is the regulatory barrier. Technical maturity does not equal legal passage. When a car without a steering wheel hits someone, how is liability defined? Regulatory differences in different regions might hinder Tesla's advantages in certain markets. Second is the ultimate challenge of safety. While V12 is very smooth, can it achieve safety levels 10 or even 100 times higher than human driving when facing extreme weather or complex rule conflicts? Even a failure rate of 1 in 10,000, when multiplied by a base of millions of cars, becomes a massive public safety issue. Finally, there is ethics and privacy. As millions of machines with high-definition cameras enter our streets and homes, how will the massive amounts of raw data they collect be protected? This remains a giant question mark. Reviewing Phil Bethel's deep analysis of Tesla, I realized that what Tesla is doing has long since moved beyond manufacturing cars. It is attempting to establish a general physical world AI operating system through FSD and humanoid robots. Over the past 100 years, the progress of human civilization has relied on energy and machinery. But Tesla tells us that the core of the next century is the scalability of cognition. When intelligence, like electricity, is injected into every car and every robot on a large scale, and at low cost through chips and neural networks, the logic of productivity will be completely rewritten. Musk once said Tesla is an AI company, and many at the time thought it was just rhetoric to boost the stock price. But through the reverse analysis of industry-leading engineers like Bethel, what we see is a far-reaching technological empire. We are at a starting point. Cars are no longer transportation, but AI with wheels. Robots are no longer science fiction, but extensions of a cloud-based brain. In this transformation, we are not just witnessing the rise of a company, but witnessing how humanity endows cold machines with intuition. Is this a fast track to an efficiency paradise, or are we personally opening an unpredictable Pandora's box? The answer might lie in the next FSD version update, hidden within that neural network that looks more and more like a veteran human driver.